Right, the first key for these problems is to recognize that soluble ionic compounds dissociate into ions when dissolved in water. So we want to recall or write out the dissociation reaction. So here's the dissociation reaction. Here I explicitly show that it's dissolved in water, but you don't need to do that. Next, we want to remember that molarity means moles of solute per liter of solution. So when we look at the unit of molarity, we're going to translate that as moles of solute per liter of solution. Finally, we're going to use our chemical equation, our dissociation reaction, to relate one chemical, KBr, to a different chemical, K+. Remember, whenever you compare one chemical to another, it has to be done on a mole-to-mole basis using a balanced chemical equation. All right, so we can see how the units work out here. Moles of KBr in the denominator cancel out with moles of KBr in the numerator, and we're left with moles of K plus per liter as our final answer. Okay, notice that our mole-to-mole ratio here is obtained from our balanced chemical equation. Now for the next problem, it's essentially the same, except we have a different mole-to-mole ratio that's determined by a different dissociation reaction. Okay, note here that aluminum chloride dissociates to 1 mole of aluminum 3+ ions. Aluminum's 3A, so it's going to go to a 3+ ion, and we have 3 chloride ions. Chloride comes from 7A element, therefore accepts 1 electron, 1 additional negative charge, so we have 3 Cl- ions. All right, so now we see how this dissociation reaction factors into the calculations in the second problem. We have for aluminum, it's a 1-to-1 mole ratio reflected here, and for the chloride, every mole of aluminum chloride gives us 3 moles of the chloride ion. So the different mole-to-mole ratios, depending on the ion that you're looking at, result in different numerical answers for the concentration of the 2 different ions. All right, we also see this in the last problem. When we look at the dissociation reaction, we're going to find that there's a different mole-to-mole ratio depending upon the ion of interest. So here's the dissociation reaction. Sodium, we know, is going to appear as a monatomic ion. This too indicates that we have 2 sodium ions, so once the compound is dissolved, we have 2 sodium ions in solution. The sulfate, as a polyatomic ion, stays together in this dissociation reaction. So here we see how that plays out. Every mole of sodium sulfate is going to release 2 moles of sodium ions, and every mole of sodium sulfate will release just 1 mole of sulfate ions. So we need to pay close attention to the ion for which we are interested in. So if we look at how these things cancel, okay, the last 2 problems, in each case we have our moles of solute is the entire ionic compound. So here we have moles of aluminum chloride canceling out, so we have a moles of aluminum 3+ ion in the first part. The second part, the moles of aluminum chloride also cancel out, but we have to multiply our numerical number by 3 because every mole of aluminum chloride releases 3 chloride ions. In the second problem, we have moles of sodium sulfate canceling out, and every mole of sodium sulfate releases 2 moles of sodium, but only 1 mole of sulfate ions.